For decades, the world's most powerful navy relied on aircraft carriers and billion-dollar warships to project strength. But these giants were never designed for the murky, everyday battles shaping modern sea power. In the shadows of distant coastlines, the U.S. Navy quietly transformed a 90,000-ton commercial oil tanker into something entirely new, a floating forward base that can change the rules of maritime conflict at a fraction of the usual cost. How did this unassuming ship become the ultimate game-changer in sea warfare? And why does its presence now unsettle both allies and adversaries? The story begins with a strategic gap few saw coming. In the years after the Cold War, the U.S. Navy found itself facing a new kind of challenge. The fleet was built around aircraft carriers, amphibious assault ships, and guided missile destroyers, icons of American sea power, but each one expensive and highly visible, tailored for high-end conflict. As new missions emerged in the 1990s and the early 2000s, including counterterrorism, special operations, mine clearing, and humanitarian response, commanders began to question whether those capital ships were the right tool for every job. Deploying a $2 billion amphibious assault ship to support a handful of helicopters or small boats made little sense, especially when adversaries could track and threaten such valuable assets with a single missile or mine. Budget realities sharpened the problem. Each new carrier or amphibious ship cost billions to build and billions more to operate over its lifetime. Yet the majority of day-to-day naval missions did not require that level of firepower or risk. The Navy needed a way to maintain presence in distant regions, support special operations, and respond to crises without tying up its most valuable warships or exposing them to unnecessary danger. The search for answers began quietly. Analysts in the late 1990s launched the Maritime Prepositioning Force 2010 study, examining how the Navy could project power ashore without relying on traditional bases or large amphibious fleets. By 2000, the mission need statement for the Maritime Prepositioning Force future called for new platforms that could serve as floating logistics hubs, aviation bases, and staging points at a fraction of the cost of existing ships. The concept of sea basing took shape, a persistent, mobile presence at sea able to support a range of missions without ever tying up to a pier. Program managers charged with turning these studies into reality faced a fundamental question. Could a commercial ship be adapted for military use, delivering the needed capabilities while avoiding the costs and vulnerabilities of a purpose-built warship? The answer would set the stage for one of the most significant transformations in modern naval logistics and warfare. At the National Steel and Shipbuilding Company yard in San Diego, engineers faced a challenge. They were tasked with transforming a commercial Alaska-class crude oil tanker into a warship that could anchor naval operations far from shore. The original hull, designed to haul millions of gallons of petroleum across oceans, measured 785 feet and displaced nearly 90,000 tons. Its size and stability, proven over years of commercial service, offered a blank canvas for something entirely new. Shipyard teams started by stripping the vessel down to its structural bones. The cavernous cargo holds, once filled with crude oil, were reimagined as spaces for aviation support, mission planning, and living quarters. Above, steelworkers assembled what would become one of the largest flight decks in the Navy, strong enough to handle the weight and vibration of 4 helicopters operating at once. This new deck, rising high above the waterline, required careful reinforcement and a network of pylons to distribute the immense loads back into the hull. Every modification was measured against the need to keep the ship stable in rough seas, a task made easier by the tanker's broad beam and deep draft. Engineers installed new power systems, aviation fuel lines, and communications arrays. The ship's silhouette, still reminiscent of its commercial origins, now concealed a web of military-grade wiring, reinforced bulkheads, and specialized equipment. The open-sided hangar space beneath the flight deck allowed for rapid movement of personnel and supplies, while cranes and ramps replaced the old oil transfer systems, enabling the launch and recovery of small boats directly from the mission deck. This layout prioritized speed of operations and adaptability. Throughout the conversion, shipyard engineers worked closely with Navy planners to ensure the vessel could support a range of missions, from helicopter operations to special forces staging, without sacrificing the reliability and cost advantages of its commercial design. The result was a ship that, at a glance, might pass for a civilian freighter, but in reality was built to serve as a persistent, flexible base for modern naval warfare. A 52,000-square-foot flight deck stretches nearly the entire length of the converted hull, making it the third largest in the Navy. 4 helicopters can take off or land at the same time, whether it is the heavy-lift CH-53, the versatile MH-60 Seahawk, or the tilt-rotor MV-22 Osprey. The deck's reinforced steel and aviation fueling lines are engineered for non-stop operations, day or night. Below, the hangar buzzes with activity as crews move cargo, prepare aircraft, and ready mission modules for the next launch. At the heart of the ship's daily rhythm is a hybrid team. Civilian mariners, many with decades at sea, handle navigation, engineering, and logistics. Alongside them, Navy officers and enlisted specialists direct aviation, plan missions, and maintain security. The civilian master keeps the ship running, while the Navy commanding officer leads operational tasking, a dual structure that blends commercial reliability with military discipline. Berthing for 250 embarked personnel means the Expeditionary Sea Base can host entire detachments of Special Operations Forces, mine countermeasures teams, or disaster relief planners. Flexible spaces below deck are reconfigured for each mission. Medical bays for humanitarian crises, command centers for regional security, or storage for unmanned underwater vehicles. The ship's cranes and mission deck allow rapid launch and recovery of small boats, supporting everything from boarding operations to search and rescue. Aviation is the core enabler. With 4 spot flight operations, helicopters and tilt-rotors ferry supplies, insert teams, and provide overwatch far from shore. Unlike jet-focused carriers, Expeditionary Sea Bases are optimized for rotary wing and tilt-rotor action, delivering persistent presence without the cost or visibility of a full battle group. The result is a platform that adapts daily, quietly extending the Navy's reach into places where traditional warships rarely go. USS Lewis B became the first Expeditionary Sea Base to be commissioned as a U.S. warship in August 2017, not in an American port, but at Khalifa bin Salman Harbor in Bahrain. The event was more than ceremonial. By raising the USS pennant, the Navy unlocked new legal authority for the ship and its crew. No longer bound by the restrictions placed on civilian manned vessels, Puller could now support combat operations under the full scope of the law of armed conflict. This change allowed the ship to serve as a true forward operating base, able to launch and recover special operations forces, direct mine countermeasures, and command maritime security missions in the heart of the Persian Gulf. Regional commanders took notice. Task Force 515, responsible for amphibious and crisis response operations across the Middle East, began using Puller as a floating headquarters. The ship's mission deck became a hub for mine-hunting helicopters and remotely operated vehicles, clearing vital shipping lanes near the Strait of Hormuz. In Africa, Expeditionary Sea Bases supported multinational exercises and humanitarian relief, while in the Indo-Pacific, they anchored persistent presence missions, working alongside partner navies in waters where permanent U.S. bases were not an option. Analysts point to the numbers. Each expeditionary sea base costs around $500 to $600 million, barely a quarter of the price tag for a modern amphibious assault ship. With that savings, the Navy can afford to keep more ships on station, spreading its presence across multiple regions at once. As distributed maritime operations become the backbone of naval strategy, commanders argue that the expeditionary sea bases' blend of flexibility, persistence, and cost efficiency is not just a budget win, but a strategic necessity. The ship that began as a commercial tanker now stands at the center of a new era in sea power. Its value measured not just in steel and dollars, but in the options it gives U.S. commanders on the world's most contested waters. In a world where contested waters define tomorrow's security, the Expeditionary Sea Base stands as proof that adaptability, not just firepower, shapes naval power. As threats shift and budgets tighten, the real test is not building bigger ships, it's building smarter ones. The future of sea control is already underway.
Before dawn, as over 140 crew members begin their routines, a 90,000-ton behemoth is already in full operation, an entire sea base built to project military power without ever asking permission from any shoreline on Earth. This floating fortress is not just the largest of its kind, it is the outcome of a radical decision made in 2015, transforming a commercial tanker into the Navy's most flexible defense stronghold. But what does daily life and relentless defense actually look like aboard a ship that rewrote the rules of modern warfare? The answer starts with the people moving through its passages right now. At 4 in the morning, the ship's corridors pulse with quiet movement. On the bridge, a military Sea Lift Command mariner checks the navigation display, eyes steady as the vessel holds position far from any land. Down in engineering, another civilian watchstander monitors the diesel-electric plant, 4 generators humming beneath thick steel decks, pushing 90,000 tons through dark water. In the forward house, Navy personnel start their own routines. The aviation boatswain's mate inspects the flight deck, running gloved hands over tie-downs and catwalk rails, while a security team checks the perimeter, scanning for threats invisible in the pre-dawn haze. The hybrid crew model is more than a roster. 44 military Sea Lift Command mariners and 101 Navy personnel share the ship, each with a distinct rhythm. The civilians called CIVMARs rotate through navigation, engineering, fueling, and damage control watches. The Navy detachment, led by an active duty captain, handles aviation, force protection, and mission command. Their days overlap, but rarely mirror each other. In the galley, a few early risers, military Sea Lift Command and Navy alike, trade quiet nods over coffee before splitting toward their stations. Rotations never stop. While one watch reads the logbook, another heads for the gym or bunks. The ship's medical officer checks on overnight reports, while a boatswain's mate tests the ship's public address system. On the mission deck, maintenance teams ready equipment for the first launch cycle. This is the lived reality of 24-hour readiness, a floating base that never truly sleeps, manned by 2 crews whose skills must dovetail to keep the operation seamless. Each action, routine or urgent, threads into a cycle designed to keep the ship on mission, no matter what the clock reads. The blueprint for the Expeditionary Sea Base began with a question. How do you deliver a mobile port, capable of supporting modern warfare, to places where no nation grants access? The answer came in the form of the Mobile Landing Platform, an experiment in using proven commercial hulls as the backbone for military operations. Naval architects turned to the Alaska-class crude carrier, a vessel known for its sheer size and reliability, as the foundation. This decision allowed engineers to bypass the cost and complexity of traditional warship construction, focusing instead on endurance and adaptability. In September 2015, the Navy formally reclassified these platforms, giving rise to the ESB designation, Expeditionary Sea Base. The transformation was more than a name change. It reflected a shift in thinking, from cargo transfer to true sea basing. The result is a ship stretching 239.3 meters from bow to stern, with a beam of 50 meters and a full load displacement approaching 90,000 tons. Beneath the deck, a commercial diesel-electric propulsion system delivers a steady 15 knots and a range of 9,500 nautical miles, enough to circle the globe without touching a pier. Inside the design offices, engineers describe the payoff in practical terms. The vast deck space allows for a 4-spot aviation layout, while the hull's stability supports heavy helicopters and tilt rotors in all but the roughest seas. The sheer volume below deck accommodates mission modules, maintenance shops, and living quarters for hundreds. Every meter of steel, every ton of displacement, is calculated to keep the ship operational far from friendly shores. What began as an adaptation of a commercial tanker became a floating fortress, one whose scale and flexibility shape every hour of its defense operation. As daylight breaks, the flight deck comes alive. The air boss stands at the edge of the 4-spot deck, headset pressed tight, voice crisp over the radio. Below, the aviation crew moves with practiced urgency, chalking wheels, checking fuel lines, and scanning the sky for the first inbound. This deck, stretching across 50 meters of steel, is the ship's beating heart. Its layout is deliberate. 4 marked landing spots arranged to keep helicopters and tilt rotors cycling in and out, even as maintenance teams hustle gear and fuel carts between sorties. On a typical morning, 2 MH-53 helicopters spool up for mine countermeasures, rotors thundering as they wait for clearance. An MV-22 Osprey idles in the next spot, ready to lift a special operations team ashore. The 4th position remains open, reserved for quick-turn refueling or emergency recovery. Every movement is choreographed by the Air Department, the bosun's mates, fuels crew, and safety observers, all working in sync. Their rhythm is relentless: launch, recover, refuel, repair, repeat. The deck never stays still for long. Each hour brings a new cycle. Aircraft launch for airborne mine countermeasures sweeps, return for hot pit refueling, and swap out with intelligence, surveillance, and reconnaissance or logistics flights. The hangar just aft of the deck holds 2 more aircraft, ready for maintenance or rapid deployment. Down on the mission deck, mobile maintenance facilities hum with activity, keeping the aviation tempo high. NAVC lists aviation, berthing, staging, and command and control as the ship's core strengths, but it is here on the open deck that those capabilities converge. The tempo is set not by the clock, but by the needs of the mission and the skill of the crew. Below the flight deck's constant motion, The ship's endurance is measured in square feet and gallons. The mission deck spans 25,000 square feet, an expanse packed with vehicles, mission modules, and mobile maintenance facilities. In the fuel tanks, 380,000 gallons of JP-5 jet fuel sit ready, managed by a military Sea Lift Command fuel chief, whose daily calculations shape the tempo of every operation. Each launch cycle draws from these reserves. MH-53 helicopters on mine countermeasures, MV-22 aircraft moving Special Operations Forces teams, and utility helicopters for logistics all rely on that uninterrupted flow of fuel to keep sorties cycling and teams in the fight. This storage is more than a number on a spec sheet. It means the ship can support complex missions for weeks without pulling alongside a pier or waiting on a vulnerable supply chain. The mission deck's footprint allows for simultaneous staging of mine countermeasures, sleds, unmanned vehicles, and Special Operations Forces boats, while mobile maintenance containers let technicians handle everything from routine inspections to major repairs at sea. A Special Operations Forces planner can brief an assault team on one side of the deck as an aviation mechanic swaps out a rotor assembly nearby, both drawing on the same core of stowage and sustainment. Every gallon of JP-5 and every pallet of gear translates into hours of aircraft on station and teams ready to move. When the ship's sensors track a new threat, or a minefield is detected in a choke point, there is no scramble for resupply. The platform is already equipped to respond. This is how the Expeditionary Sea Base turns raw capacity into strategic presence, holding its place as a floating base that can outlast the need for friendly ports. The numbers behind the steel and fuel tanks are what allow the defense operation to keep running day after day wherever the mission demands. In September 2019, the Secretary of the Navy reclassified Expeditionary Sea Bases from auxiliary status to commissioned warships. This change placed ESB ships under the USS designation, altering their legal standing and combat authority. Commanders now operate with the full rights and responsibilities of a warship, including expanded rules of engagement. The shift means the ESB is recognized as a combatant vessel under international law, not simply a support ship. For the ship's command legal advisor, this reclassification clarifies the scope for defensive actions and employment in contested waters. The platform's hybrid crew structure remains, but its operational posture aligns with the rest of the Navy's fighting fleet, ready for direct integration into maritime defense operations. On August 17, 2017, the Navy commissioned USS Lewis B Puller in Bahrain. It was the first time a United States warship was commissioned outside American shores. The event confirmed the Expeditionary Sea Base as more than a concept. It became a fixture in Fifth Fleet's toolbox, able to anchor defense operations in a region where access is never guaranteed. Since then, the Navy has steadily expanded the program. The first contracts for the class date back to 2011 and 2012, with each new hull reflecting lessons learned from forward deployment. By August 2023, construction began on Expeditionary Sea Base 8, with delivery set for 2026. Each addition to the fleet extends the Navy's ability to maintain a mobile, persistent presence, wherever the mission requires, without waiting for permission from any port. As new Expeditionary Sea Bases join the fleet, the United States Navy extends its reach, projecting force without relying on any port. In an era of contested seas, mobility is security. These ships aren't just platforms, they are the front line. The future of access is afloat. Share your thoughts below. Before dawn, as over 140 crew members begin their routines, A 90,000-ton behemoth is already in full operation, an entire sea base built to project military power without ever asking permission from any shoreline on Earth. This floating fortress is not just the largest of its kind, it is the outcome of a radical decision made in 2015, transforming a commercial tanker into the Navy's most flexible defense stronghold. But what does daily life and relentless defense actually look like aboard a ship that rewrote the rules of modern warfare? The answer starts with the people moving through its passages right now. At 4 in the morning, the ship's corridors pulse with quiet movement. On the bridge, a military Sea Lift Command mariner checks the navigation display, eyes steady as the vessel holds position far from any land. Down in engineering, another civilian watchstander monitors the diesel-electric plant, 4 generators humming beneath thick steel decks, pushing 90,000 tons through dark water. In the forward house, Navy personnel start their own routines. The aviation boatswain's mate inspects the flight deck, running gloved hands over tie-downs and catwalk rails, while a security team checks the perimeter, scanning for threats invisible in the pre-dawn haze. The hybrid crew model is more than a roster. 44 military Sea Lift Command mariners and 101 Navy personnel share the ship, each with a distinct rhythm. The civilians called CIVMARs rotate through navigation, engineering, fueling, and damage control watches. The Navy detachment, led by an active duty captain, handles aviation, force protection, and mission command. Their days overlap, but rarely mirror each other. In the galley, a few early risers, military Sea Lift Command and Navy alike, trade quiet nods over coffee before splitting toward their stations. Rotations never stop. While one watch reads the logbook, another heads for the gym or bunks. The ship's medical officer checks on overnight reports, while a boatswain's mate tests the ship's public address system. On the mission deck, maintenance teams ready equipment for the first launch cycle. This is the lived reality of 24-hour readiness, a floating base that never truly sleeps, manned by 2 crews whose skills must dovetail to keep the operation seamless. Each action, routine or urgent, threads into a cycle designed to keep the ship on mission, no matter what the clock reads. The blueprint for the Expeditionary Sea Base began with a question. How do you deliver a mobile port, capable of supporting modern warfare, to places where no nation grants access? The answer came in the form of the Mobile Landing Platform, an experiment in using proven commercial hulls as the backbone for military operations. Naval architects turned to the Alaska-class crude carrier, a vessel known for its sheer size and reliability, as the foundation. This decision allowed engineers to bypass the cost and complexity of traditional warship construction, focusing instead on endurance and adaptability. In September 2015, the Navy formally reclassified these platforms, giving rise to the ESB designation, Expeditionary Sea Base. The transformation was more than a name change. It reflected a shift in thinking, from cargo transfer to true sea basing. The result is a ship stretching 239.3 meters from bow to stern, with a beam of 50 meters and a full load displacement approaching 90,000 tons. Beneath the deck, a commercial diesel-electric propulsion system delivers a steady 15 knots and a range of 9,500 nautical miles, enough to circle the globe without touching a pier. Inside the design offices, engineers describe the payoff in practical terms. The vast deck space allows for a 4-spot aviation layout, while the hull's stability supports heavy helicopters and tilt rotors in all but the roughest seas. The sheer volume below deck accommodates mission modules, maintenance shops, and living quarters for hundreds. Every meter of steel, every ton of displacement, is calculated to keep the ship operational far from friendly shores. What began as an adaptation of a commercial tanker became a floating fortress, one whose scale and flexibility shape every hour of its defense operation. As daylight breaks, the flight deck comes alive. The air boss stands at the edge of the four-spot deck, headset pressed tight, voice crisp over the radio. Below, the aviation crew moves with practiced urgency, chalking wheels, checking fuel lines, and scanning the sky for the first inbound. This deck, stretching across 50 meters of steel, is the ship's beating heart. Its layout is deliberate. 4 marked landing spots arranged to keep helicopters and tilt rotors cycling in and out, even as maintenance teams hustle gear and fuel carts between sorties. On a typical morning, 2 MH-53 helicopters spool up for mine countermeasures, rotors thundering as they wait for clearance. An MV-22 Osprey idles in the next spot, ready to lift a special operations team ashore. The 4th position remains open, reserved for quick-turn refueling or emergency recovery. Every movement is choreographed by the Air Department, the bosun's mates, fuels crew, and safety observers, all working in sync. Their rhythm is relentless: launch, recover, refuel, repair, repeat. The deck never stays still for long. Each hour brings a new cycle. Aircraft launch for airborne mine countermeasures sweeps, return for hot pit refueling, and swap out with intelligence, surveillance, and reconnaissance or logistics flights. The hangar just aft of the deck holds 2 more aircraft, ready for maintenance or rapid deployment. Down on the mission deck, mobile maintenance facilities hum with activity, keeping the aviation tempo high. NAVC lists aviation, berthing, staging, and command and control as the ship's core strengths, but it is here on the open deck that those capabilities converge. The tempo is set not by the clock, but by the needs of the mission and the skill of the crew. Below the flight deck's constant motion, the ship's endurance is measured in square feet and gallons. The mission deck spans 25,000 square feet, an expanse packed with vehicles, mission modules, and mobile maintenance facilities. In the fuel tanks, 380,000 gallons of JP-5 jet fuel sit ready, managed by a military Sealift Command fuel chief, whose daily calculations shape the tempo of every operation. Each launch cycle draws from these reserves. MH-53 helicopters on mine countermeasures, MV-22 aircraft moving Special Operations Forces teams, and utility helicopters for logistics all rely on that uninterrupted flow of fuel to keep sorties cycling and teams in the fight. This storage is more than a number on a spec sheet. It means the ship can support complex missions for weeks without pulling alongside a pier or waiting on a vulnerable supply chain. The mission deck's footprint allows for simultaneous staging of mine countermeasures, sleds, unmanned vehicles, and Special Operations Forces boats, while mobile maintenance containers let technicians handle everything from routine inspections to major repairs at sea. A Special Operations Forces planner can brief an assault team on one side of the deck as an aviation mechanic swaps out a rotor assembly nearby, both drawing on the same core of stowage and sustainment. Every gallon of JP-5 and every pallet of gear translates into hours of aircraft on station and teams ready to move. When the ship's sensors track a new threat, or a minefield is detected in a choke point, there is no scramble for resupply. The platform is already equipped to respond. This is how the Expeditionary Sea Base turns raw capacity into strategic presence, holding its place as a floating base that can outlast the need for friendly ports. The numbers behind the steel and fuel tanks are what allow the defense operation to keep running day after day, wherever the mission demands. In September 2019, the Secretary of the Navy reclassified Expeditionary Sea Bases from auxiliary status to commissioned warships. This change placed ESB ships under the USS designation, altering their legal standing and combat authority. Commanders now operate with the full rights and responsibilities of a warship, including expanded rules of engagement. The shift means the ESB is recognized as a combatant vessel under international law, not simply a support ship. For the ship's command legal advisor, this reclassification clarifies the scope for defensive actions and employment in contested waters. The platform's hybrid crew structure remains, but its operational posture aligns with the rest of the Navy's fighting fleet, ready for direct integration into maritime defense operations. On August 17, 2017, the Navy commissioned USS Lewis B in Bahrain. It was the first time a United States warship was commissioned outside American shores. The event confirmed the Expeditionary Sea Base as more than a concept. It became a fixture in Fifth Fleet's toolbox, able to anchor defense operations in a region where access is never guaranteed. Since then, the Navy has steadily expanded the program. The first contracts for the class date back to 2011 and 2012, with each new hull reflecting lessons learned from forward deployment. By August 2023, construction began on Expeditionary Sea Base 8, with delivery set for 2026. Each addition to the fleet extends the Navy's ability to maintain a mobile, persistent presence, wherever the mission requires, without waiting for permission from any port. As new Expeditionary Sea Bases join the fleet, the United States Navy extends its reach, projecting force without relying on any port. In an era of contested seas, mobility is security. These ships aren't just platforms, they are the front line. The future of access is afloat. Share your thoughts below.
It looks like a ship, but it is really a base, a 106,664-ton floating fortress that can stage helicopters, fuel missions, and project U.S. power anywhere for weeks without touching land. No one dares attack it, not because it is unstoppable, but because hitting an expeditionary sea base means striking the nerve center of military aviation, logistics, and special operations in one move. The true power and vulnerability of this platform might surprise you. So what actually makes this sea base so untouchable? A warship sails into a crisis zone looking for a fight. An expeditionary sea base arrives to stay. The difference starts with its identity. It is not a combatant, but a floating base designed to linger where others cannot. Instead of chasing enemy ships or launching missiles, this platform serves as a persistent operating node, an anchor point for missions that stretch for weeks or months, far from any friendly shore. The United States Navy built the Expeditionary Sea Base to solve a problem that is older than modern sea power. Where airfields are too distant, ports are threatened, or allies cannot host foreign troops, the ESB becomes the answer. It is the maritime equivalent of a forward operating base, one that rides the ocean surface and moves as needed while carrying the tools of modern warfare with it. Think of it as a command center, an airfield, and a logistics hub all rolled into one hull. Its decks are designed to host helicopters and tilt rotors, support special operations teams, and stage mine countermeasure units. It can refuel aircraft, house hundreds of personnel, and store the supplies needed for extended deployments. The true value of the ESB is endurance. It can remain on station, supporting operations day after day without the need for a nearby port or base. This floating platform is not about speed or heavy firepower. Instead, it is about presence, the ability to keep a mission alive in places where the United States might otherwise have no foothold at all. Its modular design means it can be tailored for different roles, from supporting humanitarian relief to enabling mine-clearing operations or special forces raids. The ESB is not a ship that seeks out battle. It is a base that brings the fight, the support, and the command infrastructure wherever the mission demands. By anchoring operations far from land, the ESB changes the rules of engagement. It turns open water into usable territory, letting commanders project power and sustain missions in regions that would otherwise be out of reach. In this way, the ESB becomes more than a ship. It is a persistent, adaptable presence, reshaping how the United States Navy operates across the globe. A single look at the Expeditionary Sea Base reveals a vessel that defies easy comparison. At 785 feet in length and 164 feet across the beam, the Expeditionary Sea Base spans nearly as long as a Nimitz-class carrier, yet its profile is all business, boxy, utilitarian, built for volume rather than speed. The hull displaces over 90,000 tons, and when fully loaded can reach more than 106,000 tons. This mass is not about armor or firepower. It is about endurance and capacity, the ability to bring an entire support infrastructure to sea and keep it running for weeks at a time. Propulsion comes from a twin-screw, diesel-electric plant generating 24 megawatts, driving the ship at a steady 15 knots. That is not fast by warship standards, but it is fast enough for global reach without burning through fuel or wearing out systems. The Expeditionary Sea Base can cover 9,500 nautical miles at its cruising speed without needing to refuel. That range allows it to cross oceans and remain on station in distant waters, far from any friendly port. Every aspect of the design is tuned for staying power, not sprints or evasive maneuvers. The real signature feature sits above the main deck, a sprawling flight deck that stretches the length of a football field. 4 full-size spots allow simultaneous operations by heavy-lift helicopters like the MH-53E Sea Dragon, medium utility birds such as the MH-60, and even tiltrotor aircraft like the V-22 Osprey. The hangar can shelter 2 large helicopters or a mix of smaller airframes, protected from the elements and ready for rapid turnaround. This is not a token capability. The Expeditionary Sea Base can sustain a continuous tempo of rotary wing flights, day or night, with fueling, maintenance, and mission prep all contained within its hull. Beneath the flight deck, the mission bay offers 25,000 square feet of open configurable space. Modular containers can be swapped in and out, including command centers, medical suites, mine countermeasure gear, or storage for unmanned vehicles. Cranes and ramps make it possible to launch and recover small boats, unmanned systems, or specialized mission packages. The ship's design makes it possible to reconfigure on the fly, adapting to the needs of each operation without returning to a shipyard. All this capacity transforms the Expeditionary Sea Base into a force multiplier. It can host multiple detachments, aviation, special operations, and mine warfare without crowding or compromise. The flight deck is not just a platform for aircraft. It is a launch pad for missions that would otherwise need land bases or specialized ships. In practical terms, the Expeditionary Sea Base's sheer size and endurance allow it to serve as a persistent, adaptable hub, supporting complex operations in places where no other single vessel could stay so long or do so much. A single mine can close a shipping lane for weeks, halting the flow of oil, food, and supplies through some of the world's most vital choke points. The Expeditionary Sea Base, ESB, is built to keep that from happening. Its flight deck supports heavy-lift helicopters like the MH-53E Sea Dragon, each one equipped to hunt and neutralize mines from the air. Below deck, modular bays store unmanned underwater vehicles and mine countermeasure gear ready to deploy at a moment's notice. This floating platform can launch, recover, and sustain a full airborne mine countermeasures package hundreds of miles from the nearest port, giving commanders the power to clear hazards and reopen sea lanes without waiting for slow-moving convoys of support ships. But the ESB's reach extends beyond mine warfare. Its open decks and mission spaces can be reconfigured for special operations forces. These are teams that rely on stealth, speed, and flexibility. With rotary wing and tilt rotor aircraft on hand, the ship becomes a staging point for covert raids, surveillance flights, or rapid response rescues. Enemy planners can never be certain what is happening aboard, a mine-clearing sortie, a special ops launch, or both. This ambiguity raises the threat calculation for any adversary. Striking at an ESB is not just about hitting a ship. It risks disrupting a hub that might be enabling surveillance, raids, or the rapid reopening of vital waterways. The value of the ESB lies in what it enables. Its persistent presence turns the sea into a flexible base for missions that can change the course of a conflict, all without firing a shot. For those seeking to close off the ocean, the ESB is a problem that cannot be ignored. Aboard an expeditionary sea base, the human factor shapes every calculation. The crew is a blend of 34 civilian mariners and about 250 military personnel, living and working side by side for months at a stretch. These are not just numbers on a roster. Civilian mariners run the ship's engines, keep the lights on, and handle navigation, while the military detachment manages flight operations, mission planning, and security. This mix creates a unique vulnerability. Any attack risks not just military lives, but civilian casualties, an outcome that carries political consequences far beyond the battlefield. Armed defense on the ESB is sparse by warship standards. Protection comes down to roughly a dozen 50 caliber machine guns mounted along the rails. These are meant for fending off small boats or drones, not repelling missiles or aircraft. There is no armored hull, no missile interceptors, and no rapid-fire close-in weapon system. The ESB's design accepts these limits, trading heavy defenses for more space and endurance. But the ship is rarely left to defend itself. Its real shield comes from the company it keeps. When deployed to high-threat areas, an expeditionary sea base travels with a protective screen, such as destroyers, cruisers, or even a carrier strike group. These escorts carry the radars, missiles, and guns needed to face modern threats. Any attacker considering a strike against an expeditionary sea base must weigh the risk of triggering a response from the entire U.S. Navy battle group. The cost of a single hit could spiral quickly, drawing in forces and attention at a scale far beyond the value of the target itself. This layered protection, combined with the presence of civilians, turns the expeditionary sea base into a strategic tripwire. Harming it is not just a tactical move, it is a gamble with global repercussions. Right now, U.S. expeditionary sea bases quietly anchor global operations, too valuable and too connected to strike without risking rapid escalation. Their deterrent power is not just steel and systems, but the unpredictable consequences that follow. In today's tense seas, the real danger is what an attack might set in motion.
It is one of the Navy's largest and most controversial ships, born from a commercial oil tanker design and labeled by critics as an easy target. Despite its immense size and vital mission, some say it is dangerously exposed in modern conflict. If the Navy knew the risks, why did they build it this way? The answer reveals a high-stakes gamble that few outside the Pentagon truly understand. The phrase easy target has followed expeditionary sea bases since their earliest days, surfacing in defense circles, op-eds, and heated debates in Washington. Critics point to their massive size, stretching nearly the length of 3 football fields, and their slow, steady pace, which rarely exceeds 15 knots. In a world where satellites sweep the oceans and radar tracks vessels across continents, a ship this large and this slow stands out. It is visible, predictable, and in the eyes of skeptics, exposed. Analysts raise alarms about the ship's defensive limitations. Unlike destroyers bristling with missile launchers and advanced radar, expeditionary sea bases carry only basic self-defense weapons, small-caliber machine guns, and little else. They lack armored hulls, compartmentalized interiors, and automated damage control systems that define true warships. Instead, the design borrows heavily from commercial oil tankers, prioritizing cost and cargo space over battlefield resilience. Public reports and think tank studies question how these ships would hold up under missile attack or drone swarm. In recent years, the threat environment has grown more complex, with adversaries fielding precision-guided weapons that can strike from hundreds of miles away. The expeditionary sea base silhouette, easy to spot and hard to miss, becomes a symbol for everything critics fear about deploying ships derived from commercial designs into contested waters. This perception is not just technical, it is emotional. For some, the ship embodies a gamble, trading survivability for savings and risking a high-profile loss in the next conflict. That label, easy target, is not just about steel and speed. It is about trust, strategy, and the willingness to accept risk in the name of operational reach. Turning a commercial oil tanker into a forward-deployed sea base began as a problem of resources, not ambition. The Navy's program manager, facing tight budgets and rising operational demands, looked beyond traditional warship designs. The Alaska-class crude oil carrier, with its massive hull and proven reliability, offered a practical foundation. Shipyard engineers at General Dynamics NASSCO studied the Alaska-class lines, recognizing that its 785 feet length and wide beam could host both a sprawling flight deck and modular mission spaces. By using commercial diesel-electric propulsion, the team kept costs in check, approximately $500 to $600 million per ship, a fraction of what a new amphibious assault ship would require. Commercial construction methods dominated the build process. Instead of the heavy compartmentation and armored bulkheads found in combatants, the expeditionary sea base interior remained open and adaptable, echoing the original tanker layout. Engineers installed a 52,000 square foot flight deck and reinforced mission bays, but avoided costly military-grade modifications. The result was a ship built for flexibility, able to support helicopters, special operations teams, and mine countermeasure gear, all while staying within budget. The approach was deliberate. The Navy accepted commercial standards to deliver persistent presence overseas, even if it meant foregoing the hardened features of a frontline warship. For the Navy, this was less about building a fortress at sea and more about creating a platform that could do the job, affordably and at scale. Steel plates stretched nearly 800 feet from bow to stern, forming a hull as long as an aircraft carrier and wider than most city streets. Fully loaded, an expeditionary sea base displaces close to 90,000 tons, more than the weight of a Nimitz-class carrier. The flight deck alone covers 52,000 square feet, with space for 4 helicopters to operate at once. This broad expanse supports rotary wing aircraft ranging from the heavy-lift MH-53E to the versatile MV-22 Osprey, giving the ship the ability to launch and recover multiple missions side by side. Below the flight deck, a mission bay offers another 25,000 square feet of configurable space. Containers can be swapped in and out for command centers, medical facilities, or special operations gear. The open architecture allows the ship to shift roles without returning to the shipyard, adapting to missions from mine countermeasures to disaster relief. That mission flexibility is intentional. Living quarters and workspaces accommodate around 250 embarked personnel. The ship is built for endurance, with berthing, messing, and workspaces designed to keep crews operational for months at a time. Nearly 500,000 gallons of fuel are stored in tanks below, powering the ship's engines and generators and refueling helicopters and smaller vessels at sea. Every dimension, length, displacement, deck area, personnel, fuel, reflects a platform engineered for persistence. It is not just a floating base, but a node for sustained operations, able to support aviation, logistics, and command functions far from shore. The scale and flexibility are deliberate, offering a kind of staying power that few other ships can match. USS Lewis B. Puller's journey began not with fanfare, but with a budget line and a pressing operational need. At a time when new amphibious ships were topping $2 billion apiece, Puller's price tag of between $500 million and $600 million stood out. The Navy's gamble was clear: build more ships for less, even if it meant accepting commercial standards over hardened warship features. That decision would soon face its first real test far from American shores. Commissioned in Bahrain in August 2017, Puller became the first United States warship to receive its colors overseas. The choice of Bahrain was no accident. The region demanded constant mine countermeasures, aviation support, and logistics, missions that did not require a full arsenal, but did require a platform that could stay on station for months. Puller replaced the aging USS Ponce, stepping into a role that had become central to United States operations in the Persian Gulf. In the years that followed, Puller's record offered proof of concept. By 2020, the ship had supported operations involving 9 different types of aircraft and unmanned systems, working with both United States and coalition partners. More than 1,200 launches and recoveries were recorded during a single deployment. Each sortie, whether a heavy-lift helicopter for mine clearance or a tilt rotor for rapid resupply, reinforced the logic behind the Navy's investment. The numbers tell their own story. For a fraction of the cost of a traditional amphibious ship, Puller delivered persistent presence and operational flexibility in a region where both are always in demand. The ship's commercial heritage did not limit its utility, it enabled it. In the calculus of modern naval operations, the trade-off paid dividends not in armor, but in sustained, adaptable performance. A ship the size of an Expeditionary Sea Base leaves a digital footprint that is almost impossible to hide. Satellites sweep the Red Sea and the Gulf of Aden, tracking vessels as they crawl along at 15 knots. Synthetic aperture radar, commercial imaging, and unmanned aerial systems feed a constant stream of data to anyone with access, state actors and non-state groups alike. In this environment, a ship's slow, predictable course becomes a liability. Analysts warn that a vessel's position can be triangulated in near real time, making it vulnerable to targeting by anti-ship missiles or explosive drones. The ESB defensive suite is limited to crew-served machine guns, offering little protection against modern threats that arrive at supersonic speeds or in coordinated swarms. In January 2024, Houthi sources claimed an attack on a large U.S. support ship in the region. U.S. officials quickly denied any successful strike, but the episode underscored the tension. In a contested zone, even rumors of an attack can fuel concerns about the risks these ships face. Protection for expeditionary sea bases relies on the company they keep. Navy doctrine calls for these ships to operate within task groups, shielded by destroyers, aircraft, and coalition partners. Escort vessels bring layered defense. Radars scan the horizon, missile batteries stand ready, and air cover patrols overhead. In this framework, the Expeditionary Sea Base is rarely left alone. Its vulnerability on paper is offset by the force that surrounds it, turning a so-called easy target into a well-guarded asset. Flexibility is built into the ship itself. The mission deck can be loaded with containerized modules, command centers, medical bays, or even advanced weapon systems. This modular design supports expeditionary advanced base operations, allowing the ship to adapt for logistics, aviation, or strike missions as needed. Survivability in practice comes from dispersing risk across the fleet and tailoring each deployment to the mission at hand. The Navy's strategy is not to harden a single ship, but to make the entire formation resilient, connected, and ready to respond. Today, as the Navy faces rising threats and shrinking budgets, The Expeditionary Sea Base stands as a calculated risk, delivering global reach at a fraction of traditional costs. In an era defined by trade-offs, vulnerability is not just a flaw, it is a deliberate choice. The real test will come when strategy meets reality.
At first glance, it looks like a commercial tanker, 785 feet long, weighing 90,000 tons. Yet this is one of the largest, most absurdly camouflaged war platforms the Navy ever built. Designed to slip through busy shipping lanes while hiding a 52,000 square foot flight deck and a price tag that is a fraction of a conventional warship, the Expeditionary Sea Base flips every expectation. But what happens when a ship built for support, not combat, becomes critical to United States operations far from shore? The real secrets start with its unconventional design. From a distance, the ship could be mistaken for just another oil tanker making its way across the ocean. Its hull stretches 785 feet, longer than 2.5 football fields, and it carries a full load displacement of 90,000 tons. Nothing about the silhouette hints at cutting-edge military technology or secret operations. There are no sleek radar domes, no bristling missile launchers, no sign of the usual warship profile. Instead, the lines are blunt, the superstructure low and boxy, the paint scheme plain. This is not an accident. The designers leaned into the commercial look, borrowing the hull from a civilian Alaska-class tanker and keeping the outward appearance as anonymous as possible. In crowded shipping lanes, the ship blends in with the traffic, passing as just another bulk carrier or fuel transport. Yet beneath that unremarkable exterior lies one of the largest platforms the Navy has ever operated, a vessel that can support hundreds of personnel, stage helicopters, and coordinate missions across thousands of miles. The scale is staggering, but the disguise is even more audacious. The real story begins with the decision to hide military power in plain sight, raising the question, why would the Navy choose to make its largest forward base look like something so ordinary? Navy budget planners faced a dilemma: build more traditional amphibious assault ships at over $2 billion each, or find a smarter, more affordable solution. The answer came from an unexpected place: the commercial shipping world. By adapting the Alaska-class oil tanker hull, the Navy could field a massive forward base for about a quarter of the price. That commercial foundation did not just save money during construction. It also meant lower operating costs, easier maintenance, and the ability to use proven systems already common in civilian fleets. The trade-off delivered real value. These ships can travel up to 9,500 nautical miles on a single load of fuel, crossing entire oceans without stopping. Long endurance opens up options for deployment. Expeditionary sea bases can stay on station for months, supporting missions far from American shores. The cost advantage allowed the Navy to build a small fleet instead of a handful of gold-plated flagships. Every dollar saved on the hull goes back into outfitting the ship for real missions, like aviation support and command operations, which would soon become its signature strengths. At the center of the ship's transformation from an anonymous tanker to an operational powerhouse is its flight deck. Spanning 52,000 square feet, this deck ranks among the largest in the entire U.S. Navy. The scale is hard to grasp until you see 4 helicopters or tilt rotors lined up, each with its own landing spot, ready for launch or recovery at the same time. This 4-seat spot configuration is not just for show. It means the ship can support a constant rhythm of takeoffs and landings, keeping aviation missions flowing without pause. MH-60 Seahawks, CH-53 heavy lift helicopters, and MV-22 Ospreys all cycle through this deck, giving the ship reach that stretches hundreds of miles out to sea. Below the flight line, a dedicated hangar shelters aircraft for maintenance and rapid turnaround, while ordnance magazines and fuel stores keep operations going for days on end. Flight deck crews, Navy sailors, and civilian mariners work around the clock, moving aircraft, loading supplies, and keeping the tempo high. This is not just a floating platform, it is an AIIR hub, capable of launching missions far from any land base, all from a ship that still looks, from a distance, like a simple commercial freighter. Each day on board an expeditionary sea base, the ship transforms into a floating nerve center for a range of missions that rarely make headlines, but are essential to modern naval operations. The ship's cavernous mission deck houses rigid hull inflatable boats, unmanned underwater vehicles, and mine countermeasure equipment, tools that allow crews to hunt and clear sea mines in contested waters. Above, the flight deck becomes a launch pad for helicopters and tilt rotors that support special operations teams. Up to 250 personnel can embark for these missions, bringing everything needed for rapid insertion, intelligence gathering, or recovery. The ship also acts as a command and control hub, with advanced communications gear linking commanders at sea to regional task forces and joint operations ashore. When unmanned systems need to be launched or recovered, the ship's flexible deck space and cranes handle the job, supporting surveillance or reconnaissance far from land. This blend of aviation staging, small boat operations, and command facilities means the ship can adapt to nearly any task short of direct combat, serving as a persistent platform for missions that demand flexibility and reach. Authority on board an expeditionary sea base is split in a way that is almost unheard of in the Navy. Most expeditionary sea bases operate under the USNS flag, making them part of the Military Sealift Command. That means the ship's daily running, including navigation, engineering, and logistics, is handled by 44 civilian mariners, many of whom have spent their careers on commercial vessels. Alongside them, a detachment of 101 Navy personnel takes charge of flight operations, mission planning, and security. The result is a hybrid crew, with civilians and sailors living and working side by side, each group focused on its own area of expertise. This arrangement keeps costs down and draws on the best of both worlds: the reliability and efficiency of a merchant ship, combined with the operational punch of a military unit. But there are situations when that is not enough. In August 2017, the Navy commissioned the Lewis B Puller as a fully commissioned USS warship. It was the first United States-built ship ever commissioned outside the United States. That move handed authority to a Navy commanding officer, allowing the ship to meet strict legal requirements for missions like mine countermeasures and special operations. The dual status model gives the Navy flexibility, letting an expeditionary sea base act as a civilian-run support ship or as a fully commissioned warship, depending on what the mission demands. In January 2024, an expeditionary sea base played a central role in a high-stakes operation in the Arabian Sea. Navy SEALs launched from the ship under the cover of darkness, targeting a vessel suspected of carrying illicit Iranian weapons components bound for Houthi forces in Yemen. The expeditionary sea base served as the mission's floating headquarters, providing a launch pad for helicopters, a staging area for small boats, and a nerve center for intelligence coordination. Without a carrier strike group in the region, the ship's presence made the difference, enabling rapid insertion and extraction of special operations forces, real-time communication with regional commands, and on-scene command and control. The result was a successful interdiction. Iranian-made missile components and other material were seized before they could reach their destination. This operation demonstrated the payoff of the expeditionary sea base's design, its ability to support complex, forward-deployed missions without the massive footprint or escalatory signal of a traditional carrier. But the mission also reignited debate about risk, as critics questioned whether such a large, lightly armed ship could survive in a contested environment. Defense analysts don't mince words when it comes to the Expeditionary Sea Base's vulnerabilities. At just over 15 knots, the ship is slow by modern naval standards, making it an easy radar target for anyone watching the sea lanes. Its defenses are minimal. There are no missile systems, no advanced close-in weapon systems, and only a handful of crew-served guns. The ship's massive size and boxy silhouette leave nowhere to hide if threats appear. Critics argue that in a high-threat environment, a vessel this large and lightly armed could be picked off before it has a chance to respond. Navy doctrine addresses these shortcomings by never sending an expeditionary sea base into harm's way alone. Instead, the ship relies on destroyers or frigates for protection, staying behind a shield of escorts and layered air defense. The trade-off is clear. Persistent presence and mission flexibility come at the price of survivability, and every deployment is a calculated risk. 6 expeditionary sea bases form the backbone of this new support fleet, with the final hulls arriving by 2025. While small in number, these ships are spread across critical regions, from the Middle East to the Pacific, offering a persistent presence that traditional warships struggle to match. Navy planners are already looking ahead, seeing the Expeditionary Sea Base as more than just a platform for helicopters and boats. The mission decks and open spaces are designed for modular upgrades. Future versions may host unmanned surface vessels, autonomous drones, or act as mobile command posts for distributed operations. This adaptability is drawing attention from both strategists and engineers, who see the Expeditionary Sea Base as a testbed for the Navy's next generation of flexible, networked operations. Instead of building bigger ships, the focus is shifting to smarter, more versatile platforms that can be reconfigured as threats and technology evolve. Right now, 6 expeditionary sea bases operate worldwide, blurring the line between civilian and military, cost and capability. As threats shift and navies rethink presence, the ESB's unconventional form may become the new standard. Sometimes the most radical ideas quietly change the shape of power at sea. What is your take?
We are counting down the 10 most surprising facts about the largest expeditionary sea base ever constructed. From its civilian tanker origins to a flight deck longer than a football field, this platform redefines naval presence with size, endurance, and hidden capabilities you will not expect. What makes it one of the biggest yet least understood ships in the fleet? Let us start the countdown with number 10. In the 10th place, the biggest expeditionary sea base stands out for its sheer magnitude. Stretching nearly 785 feet from bow to stern and displacing around 78,000 tons when fully loaded, this ship rivals the size of Cold War-era aircraft carriers like the Kitty Hawk class. But unlike traditional warships, its vast scale is not about mounting heavy weapons or launching fighter jets. Instead, the enormous footprint is dedicated to endurance, providing space for months' worth of supplies, aviation operations, and mission modules. This makes it one of the largest platforms in the U.S. Navy, built for presence and persistence rather than firepower. Number 9. The biggest expeditionary sea base didn't start out as a warship at all. Its massive hull began life as an Alaska-class crude oil tanker, built by General Dynamics NASSCO. By choosing a commercial tanker design, the Navy sidestepped the long timelines and high costs of a custom military build. Instead of 5 years or more, the conversion from tanker to sea base took just 3 to 4 years. This approach delivered a ship capable of hauling enormous loads and enduring long deployments, all at a fraction of the usual price. The commercial routes made scale and speed possible, setting the stage for everything that followed. In 8th place, the The flight deck of the biggest expeditionary sea base stretches 160 meters, over 525 feet, making it longer than an NFL football field. This vast deck is not just for show. It is engineered to handle 4 helicopters landing or taking off at once, whether they are heavy-lift MH-53s, nimble Seahawks, or tilt-rotor Ospreys. The multi-spot layout means helicopters can cycle in and out around the clock, supporting everything from mine countermeasures to special operations. With integrated hangar space tucked beneath, the ship becomes a non-stop aviation hub at sea, built for relentless rotary wing action, not fixed-wing jets. Number 7. The biggest expeditionary sea base is engineered for endurance. It can remain on station for 45 to 60 days without needing a port. This remarkable staying power comes from massive storage tanks that hold hundreds of thousands of gallons of fuel and water, along with extensive capacity for food, spare parts, and aviation supplies. The ship's design includes robust refrigeration and dry stores, plus flexible cargo spaces that can be reconfigured for different mission loads. When resupply is needed, underway replenishment systems allow the sea base to take on fuel and materials from support ships while still at sea, keeping operations continuous. This logistical backbone transforms raw size into a persistent forward presence, allowing the sea base to serve as a reliable hub in remote or contested waters where access to friendly ports cannot be counted on. Number 6. The crew model aboard the biggest expeditionary sea base defies expectations for a ship of its size. Instead of thousands of sailors, the core team is surprisingly small, typically around 50 civilian mariners from Military Sealift Command. These professionals handle navigation, engineering, and daily operations, keeping the ship running efficiently over long stretches at sea. When a mission ramps up, the ship's population grows as Navy personnel and specialized teams come aboard, often adding 200 or 300 more. This hybrid manning approach means fewer people are needed to sustain months-long deployments, dramatically reducing costs and fatigue. Automated systems and commercial ship practices make it possible to operate such a massive platform with a fraction of the manpower required by traditional warships. The result is a lean, flexible crew that turns endurance into a sustainable reality, keeping the sea base on station where it is needed most. Number 5. Every major system on the biggest expeditionary sea base is designed around helicopters and unmanned aerial vehicles, not fighter jets. The flight deck supports simultaneous operations for heavy-lift MH-53E Sea Dragons, MH-60 Seahawks, and MV-22 Ospreys, making it a non-stop launch pad for missions such as mine countermeasures, logistics, and maritime surveillance. Aviation fuel systems are dedicated to JP-5, the lifeblood of rotary wing fleets, while maintenance spaces and hangars are tailored for quick turnaround and repairs. Below decks, a mission bay is configured to handle modular equipment and unmanned aerial vehicles, enabling rapid shifts between roles. Whether deploying drones for reconnaissance or supporting special operations, this aviation-first approach turns the ship into a flexible hub, ready to support complex missions that demand constant helicopter and drone activity, day and night, wherever traditional airfields are off limits. Number 4. The biggest expeditionary sea base entered service in August 2017, but its story begins long before that. The concept first emerged in 2011 as the mobile landing platform, designed to bridge the gap between shrinking overseas bases and the growing need for forward presence in unstable regions. As global conflicts shifted into gray zones, where carriers seemed too aggressive and land bases were politically sensitive, the Navy reimagined the platform and redesignated it as an expeditionary sea base in 2015. It was commissioned in Bahrain, becoming the first of its kind to be formally recognized as a warship overseas, and marking a turning point in United States naval strategy. This evolution reflects a new doctrine, persistent and distributed operations that keep the Navy present and adaptable, without the political baggage of traditional bases or the escalation risk of deploying a carrier. Coming to the top 3, the biggest Expeditionary Sea Base serves as a fully independent launch pad for Special Operations Forces, no foreign bases required. Deep inside its hull, a sprawling mission deck of 25,000 square feet transforms into a floating headquarters, complete with secure planning rooms, containerized command modules, and encrypted communications suites. Up to 250 special operators can live, plan, and prepare here, shielded from the political sensitivities that come with using Allied territory or local airfields. Modular mission bays allow rapid reconfiguration for everything from intelligence gathering to rapid assault, while berthing and staging areas support round-the-clock readiness. By operating in international waters, teams can launch and recover with minimal diplomatic friction, giving commanders flexibility that fixed land bases simply cannot match. This self-contained platform quietly enables missions in regions where access is denied or alliances are fragile, an invaluable advantage in today's unpredictable world. In second place, the biggest Expeditionary Sea Base redefines what military value looks like by delivering massive capability at a fraction of the usual price. The construction cost for a single Expeditionary Sea Base is $500 million to $700 million. That barely reaches 5% of what it takes to build a modern Ford-class aircraft carrier, which now exceeds $13 billion per ship. This is not just savings at the shipyard. Every aspect of the Expeditionary Sea Base, from its civilian mariner crew to its commercial propulsion systems, cuts operating expenses for each day at sea. The Navy can keep this platform on station for months, supporting helicopters, special operations, and logistics without the staggering manpower or maintenance bills that come with traditional supercarriers. By leveraging proven commercial systems and focusing on essential mission support, the Expeditionary Sea Base offers global reach and persistent presence for a price that makes sense, freeing up resources for other priorities across the fleet. In a world where naval budgets are under constant pressure, this kind of cost efficiency isn't just smart, it's strategic. And finally, in first place, the biggest Expeditionary Sea Base stands as the ultimate expression of presence without provocation. Rather than projecting power with the unmistakable footprint of an aircraft carrier or the political baggage of a foreign land base, this ship offers a third path, a quietly persistent, adaptable platform that can remain on station for months at a time. By rotating hulls and crews, the Navy achieves nearly year-round coverage in contested regions, ensuring a steady hand without triggering the alarms that come with more aggressive deployments. Experts call this gray zone deterrence, a strategy built around showing up, staying visible, and shaping events without escalating tensions. Recent deployments in the Persian Gulf and the South China Sea have demonstrated how the sea base signals resolve while avoiding the headlines and diplomatic fallout of traditional power projection. With its vast deck, modular mission spaces, and low-profile operations, the Expeditionary Sea Base quietly redefines what it means to be present at sea, delivering strategic influence not through firepower, but through endurance, flexibility, and restraint. Across all 10 facts, one pattern stands out. Naval power is shifting from sheer force to smart, persistent presence. These sea bases quietly bridge the gap between diplomacy and deterrence, proving that today's most strategic assets project influence, not intimidation. Endurance now outlasts escalation at sea.
A commercial oil tanker, redesigned as a floating airbase, hundreds of feet long and packed with secretive technology, is quietly reshaping global naval power. The official story calls it practical and cost-effective, but that leaves out the real stakes. These shadowy giants could make distant oceans feel like American territory overnight. How did an idea this bold change what war at sea means? Inside a San Diego shipyard in the early part of the decade that began in 2010, a program manager from the Navy and a NASSCO engineer met over a set of blueprints that at first glance looked like any other commercial oil tanker. The hull belonged to the Alaska class, a workhorse of the crude oil trade. But the Navy had a different vision, one shaped by years of watching access to overseas bases slip away and threats to fixed infrastructure grow. The question was not how to build a new warship from scratch. It was how to turn a proven commercial design into something the Navy could send anywhere, without breaking the budget or waiting a decade for delivery. The manager remembers the pitch. Keep the hull, keep the engines, but strip out the oil tanks and replace them with mission spaces, aviation decks, and modular support systems. The engineer recalls the skepticism. Could a civilian tanker really become a floating base for helicopters, boats, and special operations? The answer came from the mobile landing platform and the afloat forward staging base prototypes, which proved that commercial hulls could be adapted for military needs. By 2015, the Navy had rebranded these as Expeditionary Transfer Dock, known as ESD, and Expeditionary Sea Base, known as ESB, reflecting their growing role beyond simple logistics. The new designation was more than a name. It signaled a shift in thinking. Instead of relying on distant ports or fragile alliances, the Navy could bring its own base wherever it was needed. For the people behind the project, it was a lesson in pragmatism. Use what works, adapt what is proven, and build for the realities of modern conflict. Stretching 785 feet from bow to stern and spanning 164 feet across the beam, the Expeditionary Sea Base dwarfs most other ships in the fleet. At full load, it displaces close to 90,000 tons, nearly as much as a modern aircraft carrier. But where carriers are built for speed and power projection, this vessel is engineered for endurance. A diesel-electric propulsion plant drives the ship at a steady 15 knots, giving it a range of more than 9,000 nautical miles before refueling. That means it can cross oceans or remain on station for months without returning to port. Above the reinforced hull, the four-spot flight deck dominates the silhouette. This vast expanse is designed to handle some of the Navy's largest helicopters, including the MH-53E Sea Dragon, as well as the versatile MH-60 and the tilt-rotor MV-22 Osprey. Unlike smaller decks found on amphibious ships, this one supports simultaneous operations on all four spots, allowing for rapid launch and recovery cycles. The integrated hangar, carved out of what was once a tanker's cargo hold, provides sheltered maintenance and storage for aircraft and mission gear. The ship's size and design are relentlessly practical. Every inch is optimized for utility, whether supporting mine countermeasures, special operations, or logistics. The ESB does not need to outrun threats. It needs to stay put, serve as a platform, and keep operations running far from shore. The scale and capacity of the flight deck are the foundation for everything that comes next. Before dawn, the quiet of the ship is broken by the soft shuffle of boots and the low hum of machinery. Civilian mariners from Military Sealift Command head to the bridge, coffee in hand, ready to navigate the next watch. Navy personnel, in crisp uniforms, make their way to operations centers and planning rooms. The Expeditionary Sea Base, ESB, hybrid crew model brings together two worlds. About 44 civilian mariners keep the ship running, while roughly 100 Navy sailors handle mission operations and security. On top of that, the ship can host up to 250 additional personnel, special operations teams, mine warfare units, or staff, depending on the mission. Chain of command is a careful balance. The Navy commanding officer, a captain, holds ultimate authority, but the civilian master is responsible for the ship's navigation and engineering. On the bridge, a civilian mate on watch stands beside the Navy's anti-terrorism tactical watch officer, each focused on their domain. Watch rotations run around the clock, blending merchant marine traditions with military discipline. Berthing spaces are tight but functional, with men and women from both crews sharing the same corridors and mess decks. Daily life is shaped by routine, joint drills, maintenance checks, and meals that bring together people with different backgrounds and expectations. Friction sometimes flares, especially during high-pressure missions, but over time mutual respect and shared purpose foster a sense of camaraderie. For many, the Expeditionary Sea Base is less a ship and more a small floating community, one that must work together, far from home, to keep the mission on track. In August 2017, a crowd gathered at a pier in Bahrain as the Navy commissioned the USS Lewis B Puller. It was the first time a United States warship had ever been commissioned outside American waters. The ceremony, attended by senior United States and Bahraini officials, was more than a formality. With this single act, the Navy placed a fully operational sea base at the center of the Persian Gulf, a region where fixed bases are never guaranteed, and the threat of mines and asymmetric attacks is constant. The Puller replaced the aging USS Ponce, taking over as the Fifth Fleet's floating hub for mine countermeasures and special operations. Its arrival meant that United States commanders could stage helicopters, boats, and mission teams right where they were needed, without relying on vulnerable ports or negotiating new basing rights. The ship's modular decks and aviation facilities gave regional task force leaders a tool they had never had before, a persistent, mobile platform that could adapt to the tempo of crisis and conflict. For local commanders, the Puller became a symbol of American commitment in the Gulf. Its presence complicated adversary planning and reassured partners who watched shifting alliances with concern. The ship's ability to support mine-clearing teams and special forces missions, all from international waters, offered a new kind of flexibility that would soon be tested in other corners of the world. USS Herschel Woody Williams arrived in the Mediterranean as the first U.S. Navy warship permanently assigned to Africa Command. Forward deployed to Ceuta Bay, the ship operates across the Mediterranean, the Gulf of Guinea, and West Africa, regions where American bases are few and partner navies face daily challenges. Instead of relying on fixed installations, the Williams uses its endurance and modular decks to stay on station for months, rotating blue and gold military crews to keep operations continuous. During recent deployments, the Williams has become a familiar presence in the Gulf of Guinea, where piracy, illegal fishing, and drug smuggling threaten coastal nations. The ship's helicopters and small boats support maritime patrols, while its mission deck hosts joint teams for boarding and interdiction. In 2023, the Williams took part in Exercise Grand African Nemo, training alongside Senegalese maritime forces to track illicit vessels and practice coordinated responses. Earlier, the crew worked with Sierra Leone, Cape Verde, and Ghana during the African Maritime Law Enforcement Partnership, helping intercept unlicensed fishing boats and disrupt trafficking networks. This training blends operational practice with capacity building. Port visits in Lome and Tema have strengthened diplomatic ties, while the ship's ability to embark partner forces turns it into a floating classroom and command post. For African and European allies, the Williams isn't just a symbol of U.S. commitment, it is a practical tool for building skills, sharing intelligence, and responding to crises in real time. On the mission deck, a row of containerized control stations hums with activity. Operators monitor live feeds from small drones circling above the ship, while technicians prepare a scan eagle for launch. The Expeditionary Sea Base's modular design turns empty space into a nerve center for unmanned operations, supporting air, surface, and subsurface vehicles from a single floating platform. Launch and recovery gear can be swapped out as new systems come online, and the ship's communications suite links each drone to mission planners in real time. Even now, most drones are small and specialized, reconnaissance eyes in the sky or robotic boats for mine countermeasures. But every new container, every antenna added, pushes the sea base closer to a future where unmanned systems multiply its reach, letting a handful of crew project presence across hundreds of miles of open water. When the Navy reclassified the Expeditionary Sea Base from a support vessel to a commissioned warship, it was not just a change in name. The move gave commanders more freedom to use the ship for a wider set of missions, including direct combat roles under the law of armed conflict. This legal status means the ESB can operate closer to contested waters, with clear rules for self-defense and engagement. The decision also brought the ship under stricter Geneva Convention protections, clarifying the status of everyone aboard, even as debates continued over the risks faced by civilian mariners. Behind the scenes, Pentagon analysts weighed the cost savings of using commercial hulls against the need for survivability and flexibility. Shipyard advocates and regional commanders argued for more ESB ships, citing their value as floating bases that could be deployed wherever United States interests required, without the political baggage of foreign ports. In the end, the reclassification unlocked a new kind of naval real estate, mobile, adaptable, and ready for the demands of modern conflict. Today, U.S. sea bases quietly anchor influence in regions where permanent land bases are impossible. As global tensions shift and unmanned warfare evolves, these floating platforms redefine how power is projected, far from headlines, but closer than ever to tomorrow's front lines. What would you deploy from here?
A ship as big as an aircraft carrier, bristling with aircraft and special operations teams, and able to operate for months without a port. On paper, the Expeditionary Sea Base looks like a dream target for any submarine captain. But what you do not see in the title is what makes attacking it practically a suicide mission. Behind its massive scale lies a legal tripwire, a massive crew, and a response so rapid that even the most advanced submarine might never escape the hunter's net. So why does a single torpedo turn the attacker into the world's most wanted target? A vessel measuring 785 feet from bow to stern, with a beam stretching 164 feet across the water, and a displacement near 90,000 tons, does not slip quietly through the world's oceans. The Expeditionary Sea Base, ESB, is built for endurance. Its diesel-electric propulsion pushes it to 15 knots, and with a range of 9,500 nautical miles, it can operate for months far from any friendly port. This is not a warship that needs a home. It is a mobile base, designed to anchor operations wherever the Navy requires a persistent presence. The ESB's mission is versatility at scale. Its flight deck supports 4 helicopters at once, heavy-lift H-53s, nimble H-60s, and even V-22 tilt rotors. Below decks, over 65,000 square feet of mission space can be packed with vehicles, containers, and gear for mine countermeasures, special operations, or crisis response. Command and control spaces knit together the work of dozens of specialized teams. Berthing for 250 military personnel, plus a core civilian crew from the Military Sealift Command, means the ship can surge to support up to 350 people, depending on the operation. The ESB's value is not just in its size or its reach, but in the way it enables the Navy to stay forward, launching helicopters, deploying unmanned systems, and staging special operations teams in places where no port exists and no pier is needed. It is a force multiplier, offering deck space and logistics muscle at a fraction of the cost of a traditional amphibious assault ship. That persistent presence makes it a magnet for attention, and a tempting target for adversaries who see its impact on operations. But the very qualities that make the ESB so useful also make it dangerous to attack. This is not a lone ship, isolated and vulnerable. Its presence signals that layered defenses are not far away. In the calculus of modern naval warfare, attacking an ESB is less about whether you can hit it, and more about whether you can survive the response. The risk is not theoretical. When a platform this valuable comes under threat, the defensive reaction is immediate and overwhelming. For any submarine commander weighing a torpedo shot, the odds of escaping what happens next are vanishingly slim. On August 17, 2017, a United States Navy ship made history at Khalifa bin Salman Port in Bahrain. The USS Lewis B was formally commissioned into service, the first time a United States-built warship received its commission outside American territory. This decision was not a matter of convenience. For the United States Navy, it was a deliberate move to anchor its presence in a region where maritime security is never taken for granted. The puller replaced the aging USS Ponce, stepping directly into the Fifth Fleet front line, where threats to shipping lanes and the risk of sudden escalation are always close at hand. The legal status of the Expeditionary Sea Base changed again in September 2019. That month, the Navy approved the reclassification of these ships from auxiliary vessels with the USNS prefix to fully commissioned warships bearing the USS title. This change was more than a bureaucratic update. Under the law of armed conflict, only commissioned warships can carry out certain high-risk missions, like mine countermeasures and special operations staging, without legal ambiguity. The reclassification gave commanders the authority and flexibility they needed to meet challenges in volatile regions, from the Strait of Hormuz to the Red Sea. The consequences of this status are clear. Attacking a ship like the USS Lewis B is not simply a strike against a support vessel. It is an act of war against a commissioned United States Navy warship, with all the diplomatic and military weight that carries. The puller's permanent stationing in Bahrain, its ability to conduct repairs in theater, and its forward role in joint exercises with regional partners all reinforce its status as a critical node in United States maritime strategy. Any hostile action against such a ship carries the risk of immediate and far-reaching escalation, making it a far more dangerous proposition than targeting a standard logistics vessel. The Expeditionary Sea Base legal standing, anchored by the puller's commissioning and the 2019 reclassification, raises the cost and the consequences for any adversary considering an attack. A submarine commander stalking an expeditionary sea base faces a sea that is anything but empty. The first sign of trouble often comes from above. The P-8 Poseidon, a maritime patrol aircraft, can scatter up to 129 sonobuoys across the water, each one tuned to catch the faintest trace of a submarine. These buoys turn wide stretches of ocean into a listening grid, feeding data back to operators who map every anomaly, every whisper of machinery, every unnatural sound. The crew inside the aircraft works in shifts, monitoring screens, triangulating positions, and relaying contacts to the force package below. But detection is only the beginning. Once a suspicious signal appears, the response moves quickly. MH-60R Seahawk helicopters, stationed on the ESB or nearby escorts, are built for this moment. Their crews launch with little warning, flying out over the search area with a mission system that fuses dipping sonar, radar, and sonobuoy data in real time. The helicopter hovers, lowers its sonar, and listens for the telltale echo of a submerged hull. If the contact is real, the crew can drop their own sonobuoys, building a tighter net, or deploy a torpedo to prosecute the threat. This airborne layer compresses the timeline from suspicion to action. Helicopters can be on top of a contact in minutes, and their ability to hover and re-engage means a submarine cannot simply wait out the search. Every time the attacker tries to slip away, the grid reshapes and closes in. Meanwhile, the ESB's role as an aviation hub means these helicopters can cycle through refueling and rearming quickly, keeping the pressure constant. This is not a static defense. It is a dynamic hunt, with operators in the air and at sea working together to shrink the attacker's options. The doctrine behind these operations is clear. The goal is not just to detect, but to localize and prosecute any threat before it can escape. For a submarine that has revealed its position by firing a torpedo, the window to evade closes rapidly. The ocean, once a place to hide, becomes a trap lined with sensors and swift-moving hunters. A submarine captain who launches a torpedo at an expeditionary sea base does more than take a shot. He trades stealth for exposure. The moment a torpedo leaves its tube, the ocean's silence fractures. Acoustic signatures spike. Sensors across the water, airdropped sonobuoys, dipping sonars, passive arrays, begin to triangulate. What comes next is not a fair fight. The Expeditionary Sea Base defenders do not rely on luck. They deploy technology designed to cut the odds against them, starting with ANSLQ-25 Nixie. This towed decoy trails hundreds of yards behind the ship, broadcasting artificial noise to lure incoming torpedoes away from their intended target. It works across multiple torpedo guidance types, forcing the attacker to wonder if their weapon will even find the hull. But the defense does not stop at deception. For years, the Navy has invested in hard kill systems, tools that do not just confuse a torpedo, but destroy it outright. The Surface Ship Torpedo Defense Program produced the Countermeasure Anti-Torpedo, CAT, and its successor, the Anti-Torpedo Torpedo, ATT. These interceptors, just 6.75 inches in diameter, are designed to launch at high speed and detonate against an incoming threat before it ever reaches the ship. While not every vessel is equipped with these systems, their development signals a shift. Survival no longer depends on hope, but on shrinking the attacker's margin for error down to seconds. For the attacker, the calculus changes. Modern submarines like the Yasin class are powerful, 10 533mm torpedo tubes, vertical launch silos, advanced sensors. But once a torpedo is fired, the submarine's greatest asset, its invisibility, disappears. The launch gives away position. The defender's response is immediate and layered. Decoys in the water, interceptors on alert, helicopters closing in, destroyers sprinting to the scene. Every minute spent evading is a minute hunted by a network of forces trained to converge and prosecute. The ocean, once a shield, becomes a cage. In this environment, the odds of survival after firing are not just low, they collapse entirely. The submarine captain's decision to attack becomes, in effect, a decision to be found. Every commissioned warship at sea today is more than steel. It is a trigger for rapid, overwhelming response. In a world where escalation moves at sonar speed, the real risk is not the shot you take. It is surviving what comes next. What would you risk for one torpedo launch?